All right. So here we are. Hold on. There we go. All right. So here are these practice problems here that we're going to do. And again, as we work through these problems, I want you all to watch how I do them first. And then if you have questions, of course, let me know. All right. Of course, let me know. So right here, what I'm going to do, I'm going to actually show you all to prevent me from going back and forth on the periodic table. I'm just going to simply write out the charges, okay? Because y'all know I already know them, right? But because this may be your first time interacting with this, you may not be aware of those. So I'm going to actually show you how to do them, okay? So for this first part right here, it says, we want you to give the correct formula for sodium chloride. Now, here's how you're going to do this. You're going to first write the chemical symbol for sodium, and you're going to divide them up, okay? And I always tell students when we're doing this for the first time, put them in brackets, okay? Put them in brackets. Now, what you've got here, you've got sodium. And on the periodic table, sodium is in group 1. So I'm just going to simply write Na with the +1 charge. Chlorine is in group 17. It has a -1 charge. So what this means is there are charges, because they are the same, they're going to cancel out, and you're going to end up with just simply NaCl, okay? NaCl. So the charges, although they swap, but because they're the same number, the numbers are going to go away. So our answer will be letter A, NaCl, okay? NaCl. Again, we're going to keep doing these problems, so don't you guys worry about saying, okay, well, can we do another one? Of course, we're going to do another one, okay? We're going to do another one. So let me go ahead and scoot down here to number 2, okay? Potassium oxide, potassium oxide. So right here, okay, again, I'm going to simply split them down the middle. And again, I know what the charges are, but for those of you all that have a periodic table, you'll need to always keep one on standby so that you're able to know what they are, okay? So always keep one on standby so that you can practice with them and know where to find them. So potassium is in group 1, okay? It's in group 1. Oxygen, it's in group 16. Or no, I'm sorry, group 17, excuse me. No, group 16, group 16. So it has a -2 charge, okay? Because of those charges, what we're going to do is we're going to swap them. So potassium is going to take the 2, the subscript of 2, and oxygen is going to take the 1, but we don't have to write the 1. So the formula becomes K2O. Okay. Yes, oxygen is considered oxide on the periodic table. That is correct. Yes, that is correct. Okay. Now, what you're going to have right here is letter B as the correct answer. Okay. You got to remember to swap the charges. Again, what we're doing here, we're working with what's called ionic compounds. Okay. And ionic compounds are those formulas that are between metals and non-metal elements, okay? So ionic compounds is when you have a metal with a non-metal element, okay? If you remember that, this is going to help you when it comes to writing out these chemical formulas. Ionic compounds is between a metal and a non-metal element. All right, let's do number 3, okay? Number 3. So for number 3, you've got calcium and you have fluoride, okay? On your periodic table, you see it's referred to as fluorine. But for here, for what we're doing, it is fluoride whenever you combine the name. So let me give you all some pointers on that too. Whenever you have the compounds coming together, the second name becomes IDE. So instead of saying calcium fluorine, you're going to say calcium fluoride, okay? So the end, it becomes IDE. Now, again, calcium has a positive 2 charge on the periodic table. Fluorine has a negative 1 charge. Now, when they come together, the formula becomes calcium fluoride in terms of the name. Calcium is going to take the 1. The 1 is understood, so when we're writing the formulas, we don't write the 1 in. Fluorine is going to take the 2, so the 2 becomes CaF2, okay? So, Nuoff, you got to swap those charges. Swap those charges, okay? Swap those charges. So you end up with CaF2. So the answer would be letter B. In this particular example, letter B. Yes, good job. Jeff, you can bounce. You can bounce. You're being negative. Matter of fact, let me do you a favor. Because what we don't do over here is negativity. All right, he's gone. My goodness. All right, moving on. The next one. What we don't do is negativity over here on my platform. I don't. And then you're gonna come in here and be demanding. Do stoichiometry. Do, like, I see your comments, but I'm ignoring you for a reason. All right, y'all. Sorry. Rewind. Whoop. All right, here we go. So for this formula here, again, calcium took the 1, fluorine took the 2, and so they swap charges, so you get CaF2. Okay, now we're going to keep going. Okay, let's look at magnesium sulfide. Magnesium sulfide. Again, you've got the chemical symbol for magnesium. It's Mg, and the charge is with the positive 2. Sulfur, okay, is the symbol S, and it has a charge of negative 2. Now, again, when the numbers are the same, they cancel each other out, so you're just left with MgS as your final formula, okay? So whenever the numbers are the same, they cancel each other out, okay? So you'll notice that the answer choice is letter A or letter D. Well, the two 2's are going to be what you call reduced to the lowest common denominator. So in chemistry, whenever the numbers are multiples like that, when you have Mg2, S2, you can divide both numbers by 2 to get it in the lowest common denominator, which is MgS. Oh, thank you, Tiara. Appreciate you. Good job, Nuoff. That's right, MgS. Very good, very good. All right, take a look at number 5 now. Number 5. You've got aluminum oxide, okay? Aluminum oxide. Excuse me. Now, aluminum oxide, again, the symbol is Al, okay? And I'm going to actually let you guys do this one, and you could put your answer in the comment box. So you've got Al, and aluminum has a positive 3 charge. Oxygen has a negative 2 charge. So in the comment box below, I want you guys to put your formula for that one, okay? Give me the letter A, B, C, or D. A, B, C, or D. And this is so annoying whenever, like you have, when you're writing out documents in Microsoft Word, you have to constantly tell it that these are all the correct ways to write. So yeah, okay, hold on, y'all. I'm trying to get rid of all of these. Okay, so yes, so number 5, I see several of you all have written D. You are correct. That is correct. Again, all you're doing is showing how you're swapping them. Aluminum gets the 2. Okay, so Al2, and then oxygen gets the 3. O3. And the name of this is aluminum oxide. Aluminum oxide. Good job, guys. Good job. Good job. Now, I'm going to give you the name or the formula. You have to now give me the name, okay? So I'm going to give you the formula, but you have to give me the name. So let me do this. Hold on. Let me see right here. Because I want to make sure that you all can do both ways, okay? You will have to do them both ways on your assessments, on your exams. So let me go ahead and copy some of those out for you so that I can know for sure that you can do that. Okay, let's see. And again, I will provide you all with the charges so that you don't have to worry about writing the charges. I mean, because I don't want to keep going back and forth with the periodic table, okay? So, and it's just easier for me to do it this way, okay? Okay, hold on, y'all. Okay, any questions so far from anybody based on what we're talking about this morning? Any questions from anybody? You have a problem naming them. Okay. All right. Well, I'm gonna show you what to do. Okay. So here's an example right here. Okay. So let me go ahead and make this a little bit bigger. And then I'm gonna show you how to name them the reverse way. All right. So don't you stress. I got you. All right. So here is your element right here. Whoops. Okay. Here's your element right here. You've got SR. And then you have Cl2, okay? Sr, and then Cl2. Okay, what you need to keep in mind is that the first element here is a metal. So if you were to look at your periodic table, you will know that the first element is a metal. Okay? If you know that the first thing is a metal, and the last thing is a non-metal, you have to know that they are going to be pronounced as you see them. You're going to call it like you see it, okay? You're going to call it like you see it. So in other words, SR stands for strontium. Strontium, okay? That's the first name, strontium. The second name, you see that Cl? Well, you know that chemical symbol is for chlorine. But instead of saying chlorine, you're going to say chloride because the ending changes to IDE whenever you're writing the formulas out. Okay? So again, when you look at the correct, strontium chloride, exactly. If the first name is a metal, the second name is a non-metal, that's what you go by. You just call it like you see it. When you have two elements, just the two elements, first name, call it like you see it. Second name, change the ending to IDE. When you have and this, by the way, is referred to as an ionic compound, okay? Ionic compounds is when you have a metal plus a non-metal element that comes together. That's where you have an ionic compound, okay? It's not difficult, but again, I know for the first time or the second or third time, it takes practice to make this digestible, okay? Let's do another one. Let's do another one. Okay. So I'm going to erase this name right here, and I'm going to give you a different element. Okay, let's see. Okay. So here is the second one right here. BaI2. No, hey, baby boy, I don't do organic chemistry, but I can give you some people that do. Just DM me and I'll give you who I would recommend. All right. So what's the first name? What do you all think the first name is called? And then what do you think the second name is called? And remember, barium, oh, I just kind of told you, Ba is a metal and I is a nonmetal. Okay, hey, Austin. Sally, okay, Sally said barium iodide. Yes, and Austin, both of you all are correct. So the first name, yes, is barium. We're just going to call it like we see it, barium. And then on the periodic table, we know that it says iodine, but instead of saying iodine, we're going to say iodide, okay? The ending changes to IDE. So you end up with barium iodide as your name, barium iodide. Okay. Okay, so Nuoff, is this giving you further clarity now? Like, do you understand it a little bit better? Okay, yes, a little bit. Okay, so let me insert a periodic table again, so that way you can see some further processes here in terms of how we actually go about naming these compounds, okay? So as you can see here, this is your periodic table, right? Remember, any element that you are combining from group 1, and let me put the charges here, group 2, we're going to skip groups 3 through 12 for a second, group 13, and group 14, any of those that combine with group 15, 16, 17, those are going to be your ionic compounds, okay? So anytime the red combines with the purple, in this particular example right here, if they combine together, those are going to be your ionic compounds, and they're going to swap charges. So for instance, we're going to get into the ATEs later, yes. Why don't we have to say a charge for the nonmetals? Well, oh, good question. Okay, I know what you're asking. The elements here that are in groups 3 through 12, some of them have multiple charges. The ones that have multiple charges, you would identify them accordingly in Roman numeral. But we're going to get to that part in a minute, okay? What I'm doing is showing you all how to write formulas first, the basic way. Then we're going to rev it up a little bit and get into those elements that have more than one charge. So for right now, we're just doing ionic compounds where you're just swapping charges and naming them. So let me give you one more example like this, or a couple more. Let's say that you have calcium, which is right, and I'm gonna highlight them so that you all can see it, okay? Calcium and nitrogen. Okay, now I just highlighted 2 elements. I want you all to give me the charges for those elements, okay? Give me the charges. So I'm going to write them underneath it. Don't give me the formula yet, just give me the charges for each of those. The 2 that I highlighted in yellow. So what's the charge for calcium? What am I going to write underneath it? Thank you, she means business. Very good. Very good. +2 and -3. Excellent job. So +2 and -3. Now, what are we going to write as the final formula? What are they going to do? Good job, Nuoff. Good job, Danny and Sally. Yes, good job. If they swap charges, I want you all to write in the comment box the formula for this and name it. I want you to write the formula and name it. Okay. All right. So far, I see a lot of you are writing out the correct formulas. Okay. So yes, I'm going to write it over here. Ca subscript of 3 N subscript of 2. Give me the name of this formula. Write the name of it. Good job, Nuoff, calcium nitride. Good job, Danny. Good job, SZA. Good job, Sally. Good job. You all did a really good job. Now, Kalos toes, MC toes, it would not be called calcium dinitride because we have not gotten into those just yet, okay? Thank you, thank you. Yes, we have not talked about numerical prefixes yet. So that's why we have not talked about those. So you will not hear me say those names just yet. But in this case right here, we're just calling it like we said, calcium nitride. Okay, calcium nitride. Okay, now let's do another one because I want to make sure that you all are good before we move forward to revving it up. Okay, so I'm going to give you all 2 different elements. Okay, let's look at potassium and oxygen. Well, no, we already did that one. We already did that one. Let's do potassium and bromine. Okay, let's do those 2. Calcium and bromine. Tell me, what's the formula going to be with potassium and bromine? Potassium and bromine. Okay. Okay, you guys are doing good. Yep. They both have 1s, but the 1s are going to cancel out. So you're going to end up with just simply, yes, KBr. Now, what's the name of this formula? Name this formula. Name this formula. Okay, yes, you all got the formula right. You got the formula written down, but name it. Give me the name for this. Good job, George. Good job, Dar. Good job, Danny. Good job. Potassium bromide. Excellent. Excellent job. Potassium bromide. Okay, you guys are doing excellent. Now we're going to rev it up a little bit, okay? We're going to rev it up to our next part right here. Okay. Well, let's see here. Okay. A lot of you all were wanting to get to the part of those that have more than 1 charge. So let's go ahead and talk about those elements that have more than 1 charge, okay? Because they're there, you all need to be aware of that fact, okay? So let me go ahead and swap my screen out so you all can see this. And here's the thing. When you deal with those elements that have more than 1 charge, you have to call them like you see it, okay? These are called writing formulas with more than 1 charge, transitional metals, and variable charges. Now, I do have a chart that has all of this on there, okay? If you want to get access to it, you can be a part of my membership and you can get access to all of these worksheets that you see me working with, okay? If you want access to them, okay? And what I do, I put all these extra notes on there for you all so that you know how to easily solve these problems, okay? Now, here's something else that you all need to know in your notes. With those that have more than 1 charge, we denote them by Roman numerals. So for instance, if I see that iron has a positive 2 charge and a positive 3, for the one that has a positive 2 charge, I'm going to say Roman numeral 2. For the one that has a positive 3 charge, I'm going to say Roman numeral 3. So you still are going to crisscross or swap the charges, but when you write the formula in, you're going to write it based on the Roman numeral for that charge. Okay, so let me bring up the periodic table that we were looking at previously right here in the middle. Okay, as you guys can see, I'm just going to identify some of these elements that have more than one charge, okay? Some of these elements that have more than one charge. And listen, you guys need to be familiar with those for a number of reasons. The reason is because these elements here are going to be on your test. So if you're taking the TEAS exam, or if you're in your chemistry class, these are the ones that you have to know, okay? These are the common ones. Iron, okay? So you've got iron, you also have copper. And I'll tell you what they are in a second, okay? So hold on. You have iron, you have copper. Also over here, you've got tin. Now, tin and lead aren't part of the transition metal groups, but they also have more than one charge, okay, as well. So we're just going to deal with these four for right now, okay? We're just going to deal with these four for right now. Iron charge is either +2 or +3. Copper is +1 or +2. And tin and lead is +2 and +4. And I'm going to write that small if I can. I know it may be hard for you all to see, but maybe you can hear me say it, that tin and lead has a +2 charge and a +4. But again, I'm going to write those down in here. Okay, good. You lock in? Good, Strawberry. Good. All right. So let me, and here they are again. Okay. This is on that sheet that I was just telling you guys about. These are the ones that have more than one charge. Okay. So for instance, let me give you an example. If I told you to write the formula for, let's say, iron, Roman numeral 3, oxide, okay? Let's say that that was your formula that I told you to write out. What you're going to do is draw a line down the middle. And right there, I'm telling you what the charge is for iron, because iron has more than one charge. Iron has a +3 charge in this case. So I'm going to write +3 underneath iron. Oxygen, we know from our periodic table, has a -2 charge. So whenever we do the swapping, again, iron is going to take the 2. Whoops. And oxygen is going to take the 3. And so that's your formula right there, Fe2O3. So why do they have to have different charges? It's for stability purposes. Kind of like, well, okay, hold on. Let me, without saying the wrong thing. Okay, well, I'm just going to say it. So you know how it is, like we had a person that came in here earlier trying to start some mess. Now, I'm cool and everything, but if you get on my bad side, it ain't going to be a good thing. So I have another personality that'll come out. So in other words, depending on the environment, it alters its charge accordingly, but the charges are for stability. Some of these, like for instance, with copper. Copper is a very beautiful, beautiful color whenever it combines with other elements. You can have copper 1 or copper 2. One of them is going to give you like this bright greenish color. The other one's going to give you like this bluish greenish color. So they have different characteristic traits that illustrate stability for their multiple charge format. Okay, that's the long, short story version. All right, so whenever you name them out, you've got to put the Roman numeral in their name to identify what charge are we going to say this element has. So if I say, if you just said iron oxide, that would be wrong. You have to say iron Roman numeral 3 oxide, or iron Roman numeral 2 oxide. Whatever the charge is, you have to say what it is, okay? Yeah, of course, Audrey, of course, okay? All right, so let me give you all another example before we actually do some more where you have to pick the right one, okay? So let's say that I gave you copper 1 oxide, okay? And I said, write the formula for copper 1 oxide. Okay, we're gonna draw a line down the middle. In this case here, copper 1 has a +1 charge, okay? Oxygen has a -2 charge. So when they swap, copper is going to take the 2, so you're going to write the subscript of 2 there, and oxygen is going to take the 1, but the 1 is understood. Okay, so Nora said, how do they balance if they have different charges? Well, it's not about balancing. It's about writing the charges that they have been assigned, and they're just coming together. So it's like a relationship. It's not going to always be 50-50. It may be 60-40, 30-70, 90-10, depending on the situation. So it's not about balancing the charges, but instead just swapping the charges. So don't overthink it. Just simply know that you're going to swap their numbers, okay? Copper is going to take oxygen's number, and oxygen is going to take copper's number, and you're going to write them down. So Cu2O would be the formula for this one. Now, I'm going to move this over here, and I'm going to show you all how sometimes things look funny, okay? So let me show you what I mean by that. When I move them over, okay, you're going to see what I mean by how they look funny, okay? If I give you the same formula name, but this time instead of saying copper 1, I'm going to say copper 2 oxide, okay? Copper 2 oxide. There is a difference in the way they are written, okay? Copper 2. So right down the middle, I've got Cu. I told you copper 2 this time. And oxygen has an O. And again, it still has a -2 charge. So what's going to happen? Those two numbers are going to cancel out. So in this example here, the formula name becomes CuO. That's the formula name for copper 2 oxide. Okay, so do we just change the charge? Yes. Yes, we just changed the charge in this example. The way that I wrote it in purple and blue is for copper 1 oxide. The way that I wrote it in red and green is for copper 2 oxide. Two totally different formulas. Just like we could have Jane Doe and Johnny Doe. Two different formulas, or two different names, two different people. They look similar, but they are different, okay? They are different. So again, you just have to remember to write the formula with the charge that is assigned to it. So let me give you another example. When we have similar charges, it can't, that's right, when the numbers are the same. Don't worry about adding and subtracting. No, it's not about adding and subtracting. When one is positive and the other one is negative, the same number, they cancel each other out. Yep, they cancel each other out. Okay, so let me show you another example, but this time I'm going to have you all name it. Okay, you're going to have to name this. So let's say that I gave you PB, let's see, O. Okay, PBO. So take a look up here. I'm highlighting lead names that you all can use here. Okay, thank you, no problem. I'm highlighting the potential names. I want you all in the comment box to write out the name of this formula right here. Okay, so in the comment box, I want you to write the name for this formula. Okay, guys, look at your answers. I see a couple in the comment box, but okay. So, hey, yes, okay, here it is. All right. Right there, you know it's going to be either lead 2 or lead 4. Well, here's how you know which one it is. I know that oxygen only has a -2 charge. I know that lead 2 has a positive 2, and because I don't see any numbers in the blue formula, that means the two 2's canceled out. So this name would have to be lead, Roman numeral 2, oxide. You just can't say lead oxide. You have to identify the charge, just like, you have to identify the charge, okay? You got to identify who you are, what you are. Lead 2 oxide. If you just say lead oxide, I don't know if you're saying Roman numeral 2 or Roman numeral 4. You've got to identify it. Now, so if this is the formula for lead 2 oxide, okay, let me go ahead and move this over. I'm just going to go ahead and write the formula name. If this is the name for lead 2 oxide, PbO, okay, what happens if I now tell you to write the name for, let's say, lead Roman numeral 4 oxide? There is a difference. Lead Roman numeral 4 oxide. Okay, you see it now? Good. Wait, when we have similar numbers of charges, doesn't it cancel out? Yes. You don't see the 2's anywhere in the formula. That's why it's just PbO. That's why it's PbO. So, what if I gave you lead 4 oxide, Pb with a positive 4 charge, oxygen with a negative 2 charge? Okay. And guys, make sure y'all tap this screen, run them up to like since we got 42 people, run those hearts up to 4,200. Can y'all do me that favor? 4,200. Now we got 45. Yeah, run them hearts up. Tap, 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 tap. Tap, 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 tap. Okay. So now I see 2 different answers. Thank you, Gio. I see 2 different answers in the comment box. You're both right, but let me tell you why on a technicality. Okay. So remember how I said they're going to swap, right? Pb gets the 2. Oxygen gets the 4. Here is the deal. In chemistry, we don't want to leave the answer as Pb2O4. Instead, we're going to reduce it down by dividing both numbers by 2. So you end up with PbO2. Okay? PbO2. Okay. Don't overthink it. PbO2. Good, light 2323. Good, 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 good. Okay. Thank you. She means business. So y'all, again, please don't make this hard. What I'm trying to do is take it piece by piece, a little at a time, so you all can see how simple this would be. And yes, you would just simplify it. Yes. So all you have to do, okay, again, you originally had PB2O4. This wouldn't be wrong, but it's just not right completely as far as the answer that you would see on your test. You would have to reduce this down to the lowest common denominator so the 2's get canceled out and you get PbO2. Now, I know that this formula would not be called lead 2 oxide. If you write lead 2 oxide for this, that means the 2's did not cancel out. See, remember in the previous formula, lead 2 oxide was PbO. That's lead 2 oxide. This one here is lead 4 oxide in the reduced form. Okay? Whoops, just so you all can see that. Right there. Okay? Now, of course, we're going to do some practice problems, okay, in the multiple choice format, because you may see these again in some form or fashion, okay? So y'all know I'm going to give you all some practice problems to make sure that you have this down pat. Okay. And again, guys, I don't want y'all to overthink it. Don't overthink it. Okay. So let me give you some practice problems just to make sure that you guys are good. I know you are, but I want to make sure. Okay. So Roman numerals are only used for transition metals. Yes, transition metals plus lead and tin. Lead and tin aren't transition metals, but yes. So let me go back to my periodic table so you can see this. I may have, okay, I changed the screen. Oh yeah, here it is, right here. So I'm gonna highlight them in a different color so you can see it. Okay, so right here, I'm gonna highlight it in pink, okay? Iron, copper, and these are just some of them. Some of these other ones have more than one charge, but I'm just dealing with the ones that are the most common for right now, okay? Lead and tin over here, let me undo it. I'm gonna put those in a different color. Purple. Lead and tin are not part of the transition metals, but they also have more than one charge. They have a charge of +2 and +4. Okay, +2 and +4. The light grays on the periodic table are radioactive elements. The ones that are radioactive elements are light gray. The ones that are dark are your metals, and they're in solid form. And then there are others that are in red. Those are your gases. And there are two that are blue, and those are in liquid forms. Okay, now let's go to these practice problems to make sure that you're welcome, to make sure that you all understand this. So let's do this one right here. Now, guys, if you all want to, this is one of those freebie videos that you can actually get, because I'm actually live on YouTube doing this. But the drawback to the video online versus the one in my membership is that I edited out. So when I went off on that person earlier, you won't get that in the edited video because you don't want to hear that again. And then two, you also get worksheets. I have 4 to 5 worksheets a week that I give out. That what you guys see on the portal, I mean, what you guys see here, they're in my membership portal. Okay. You're welcome, Ivy. Hey, Andrea, how are you? All right. So let's see what the answer is for number 11. We've got iron 2 oxide. Iron, Roman numeral 2. Oxide is O with a -2. What's the formula going to be? Excuse me. I see A and I see B. Make sure y'all look closely at what these two twos are going to do. We haven't gotten to covalent bonds yet. We're going to do that next. So just hold on. We're going to get to covalent bonds in a minute. Okay, good job, Sparkle. They cancel out. Nia, you got it right. Who else? Nichelle, you got it correct. Yep. Ari, you got it correct as well. They cancel out. So the answer is letter A. Letter A. Okay, look at number 12 now. Number 12 here in this example. Iron 3 oxide. Iron 3 oxide. Again, iron 3. So I'm writing the charges underneath them. Oxide is -2. And remember, they're going to swap. Iron takes the 2. Oxygen takes the 3. Now, let me tell you, I could have very well put on here where you did not swap the charges, and I could have said Fe3O2, And that would be wrong if you did not swap the charges. So yes, you've got to make sure you all swap the charges. So yes, excellent job. All of you all that got D, way to go. Very good job. Very good job. Y'all are on point. Y'all know what you're doing. I love it. Can you all do number 13? Number 13, copper 1 chloride. Copper 1 chloride. Oh, thank you. You got this, Noah. You got this. You got this. Copper has a positive 1 charge. Chlorine has a negative 1 charge. So what are those ones going to do? Cancel each other out. So what's the correct answer for this one? Good job. It is letter A. Excellent job. Excellent job. Way to go, guys. Way to go. Ashley, we talked about this before you came in. I actually took my periodic table and I identified what each group number has in terms of their ionic charges. So this chart that you guys see right here, this is how we know what the charges are for each of those elements. Yep, this is how you know what the charges are for each of the elements. Okay. All right, guys. Y'all are doing really good. You just got to take your time. You just got to take your time, and before you know it, you will get it. Okay? Oh, Ashley, you're taking the dental hygienist exam. Okay, in 65 days. Well, listen, if you need a refresher course for $19 a month, come be a part of my membership and you'll get access to all these worksheets. We already have a month's worth of information in the portal already. That's already being released. And if you bring a bestie, you'll save and they'll save also. Okay, because sharing is caring. So why should you not get the discount if they're getting a discount? So yes, guys, if you all are in the membership, the more people you tell, you almost can literally get a free membership. And they'll keep getting the discount also, like each month. So for $19 a month, that's pennies. That's not even $1 a day worth of information that you guys are getting. Okay? Not even $1 a day. So yes, if you all need a refresher course on all the chemistry that you want to know about, hey, you all can be a part of this portal. Okay? And it's basically $1.57 a day. Okay? So let's go back to our next problem right here. Let's see. Number 15, right here. Number 15. Okay. What is the answer? Well, I am your professor right here. So listen, we get together 4 days a week, 5 on Fridays when we do our game time. So yes, I'm basically your virtual professor. Mm-hmm. Ball of 30. We ain't talking about that right now. We're doing formula writing for right now, okay? All right. So let's look at number 15. Lead 2 sulfide. Lead 2 sulfide. Again, they told you which charge for lead 2, and then sulfur has a charge of -2. Okay. Yes, if you guys got A, you are correct. A is correct. Yes, very good, very good, very good. All right. Now, Yes, lead is either +2 or +4. So let me go over here so you can see. Right here in the middle, it's +2 or +4. See this part in yellow? Lead could be +2 or +4. Okay. You want to do it again? Okay, let's do that one again. Okay, it was lead 2 sulfide. So, and here's sulfur so you can see. So I'm gonna highlight them for you, okay? So here is lead. Well, yes. Okay, so here's lead, but they told you lead 2. Here's sulfur, which has a -2 charge. So putting those two together, Pb and S, you just get PbS. Like here in our state, we have a channel called the PBS channel. Okay. That was the educational channel. So yes, number 15 was PBS because the two twos canceled each other out. Yes. All right. Now, we just talked about two different types of examples, okay? But so before we move on, let me refresh and review what we just learned. The first example was talking about metals and nonmetal elements called covalent compounds, okay? So that's when you are swapping charges, metals with nonmetal elements, swapping charges, metal and nonmetal elements. A metal combined with a nonmetal element swaps charges and you call the name as you see it. The second example that we just dealt with were with your transition metals, where the transition metals have more than one charge. So we would say Roman numeral for the charge, like lead to oxide. We told you lead to oxide. We're telling you lead has a charge that we're going to use for Roman numeral 2. Okay? How do you identify ions and cations on an exam? Good question. They're charges. So right here on the periodic table, remember anything that's positively charged are cations. Negatively charged, think about negatively charged, they're negative. A good example, based on what you just asked me, that was a very good question. Suppose I told you to identify the charge on this element, Mg, and then let's call this X, okay, element X. If this is the formula that you saw right here, what would the charge be on X? What would the charge be on X? Meaning, when they swap charges, it would have to have a charge of 2 on the side. So this element here could be magnesium chloride because magnesium has a +2 charge, and this X element has a charge of -1. And how do we know it's 1? Because there is no number assigned to magnesium once they swap. So you end up with MgCl2, for instance. And if we were looking at for X, the X would be chlorine. Okay, now, again, I don't want y'all to overthink this because you know what we're getting ready to do next. I'm going to say polyatomics for tomorrow. But we're going to do covalent compounds now. Covalent compounds. Okay, you're welcome. Covalent compounds, okay, right here. Covalent compounds are between two nonmetals. Two nonmetals. And you use numerical prefixes in the name. two non-metal elements using numerical prefixes in the name, like carbon dioxide, carbon monoxide. So at what point do you use the numerical prefixes in the name? When they're both the same. Okay, now again, y'all, as a chemistry professor, I have to liven my lessons up. So I have to give out crazy examples to help you understand and digest it. So as an example, when they're the same, two men, two women, okay, they're the same. Man, man, boy, boy, girl, girl. Orange, orange, apple, apple. Covalent compounds. They are basically two of the same things, okay? Two of the same things. Oh, you're going to see this here because this is naming formulas. So you will see naming formulas on your TEAS exam. Yes, naming formulas on your TEAS exam. And this is like the foundation really for chemistry. There are typically 9 questions on the TEAS exam for chemistry. 9 questions. And they do throw out a few of them, but with the 9, I mean, we're covering like 14 topics, but you only have 9 questions. You know what I mean? Like, it's like, wow. You got to learn all this stuff just to only be given 9 questions. I know. With those numerical prefixes, mono means 1, di means 2, 3 means tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nano. Like it just continues. But these are like the common prefixes, the top 8. Again, when you have the numerical prefixes within your name, okay, as an example right here, you're gonna, the first symbol is the first nonmetal. The second symbol is the second nonmetal. And you're gonna write the prefixes as you see them. So in the example here, carbon dioxide, you're gonna say CO2. Carbon dioxide. O2 is dioxide. Versus carbon, C, monoxide, 1 oxygen, O. So CO. I believe that these are easier to do, and here's why. Because you're just naming them according to the prefix in the name. Di means 2. Nitrogen means N. So when you write this, you write N2. Penta is 5, like the pentagon. Penta is 5. Oxygen is O, so you rewrite that as O5. Now, in chemistry, it's almost like learning English. Technically speaking, it's penta, but when you have 2 vowels side by side, you'll notice that the A goes away and you just have pentoxide, okay? So rather than saying pentaoxide, it's pentoxide. FYI, okay? FYI. Hello, Anastasia. Yes, it's better to memorize them, but it's not difficult to do because of the names. Like right here, put them on index cards. Mono, 1, di, 2, tri, 3, tetra, 4, penta, 5, 5 sides, 6, hexa, 7, hepta, 8, octa. Okay? Leah, you asked, how do you know if there's covalent or ionic? Okay, ionic, remember, ionic bonds or compounds is metal plus non-metal. What we're talking about now are covalent compounds, and those are 2 nonmetals combined together. 2 nonmetals combined together, okay? Nonmetal plus nonmetal. So, hey, Lynette, we're going to do polyatomic ions tomorrow because based on what we've done today already, we're dealing with 3 different formula types. Polyatomics, they need a whole day to themselves. I appreciate you asking that though. Um, again, it's from the periodic table. So I know some of you all are trickling in for the first time. Uh, again, most chemistry teachers will tell you to color code your periodic table. 85% of your elements on your chart are metals. So pretty much, I'm just gonna highlight this part right here. Most of these right here, matter of fact, all of these right here that I'm color coding, these are all metals right here. On this green staircase are your metalloids right here, okay? That means they go both ways. And then over here in purple, okay, these are your non-metal elements right here. These are your non-metals right here. And how you know also is because they are highlighted with the negative charges. Negative charges are non-metals. The red ones are your metals. So that's another way that you can tell. Okay? That's another way that you can tell. Oh, Noah, I actually did isotope abundance last week. Yeah, with percent abundance, I did those last week. Yes. Yes, you're welcome. All right. So now I'm going to go over here and we're going to practice writing out a few of these examples, okay? So we're going to practice writing out a few of these examples for your I say poly because I'm looking at polyatomics. A few of these examples with covalent compounds, okay? So we're just going to do a few. Yes, I go live at the same time every day. Make sure you guys are following me. I go live Monday through Thursday at 10 a.m. Some Fridays, depending on what we're doing, at 10 a.m. as well. But yes, Monday through Thursday at 10 a.m. 10 a.m. Yes. Now I need to start doing some stuff for my General Chem 2 students because I know a lot of you all have questions about like I see right here you got ice tables, gas laws, stoichiometry. See, and I normally don't cover that until like the second month of the semester, but I will be doing some videos, but I do have them on my YouTube channel. I do have the ice tables and the gas laws, and I also have some here on my playlist. So yes, if you can go and find them on the playlist, you will have access to the ice chart. Yeah, yes. So I will be doing stuff for my General Chems 2 students as well. Usually, well, what I've started to do now is to kind of change things up and use like the last, 10 minutes of class to help students who are in other classes. So after I finish my lesson, I will entertain a few of y'all's questions, okay? So now we're almost at 10,000 hearts, guys. We're almost at 10,000 hearts. So make sure that, thank you. You know what? Thank you, Nuaf. I know that some students do not like chemistry because of the negative experience that they have had with it. But this is why I tell students all the time, you have to have the right teacher in order to make you have thank you so much for the subscription. I appreciate you. You have to have the right teacher because it can leave a negative connotation in your mind about chemistry. So trust me, I get it. I get it. I get it. All right. So we're going to continue these problems right here, y'all. And what I want you guys to do is to think, I do have a subscription here on TikTok. Now, the difference between that one versus the one on my own portal or my membership, the membership works where you actually get these worksheets right here. Okay. You do get copies of these worksheets in my actual membership, and it's in my profile. So if you click there, you can look at more about how I do the membership. You get all these replays that are edited, so you don't have to hear this extra talk. And then you get like 4 to 5 worksheets a week. And when I say worksheets, I mean they're like 10 to 15 pages a piece. Okay? Because I give you all so many practice problems and quizzes that you can actually practice with these questions to see what you know. Thank you. I appreciate. Oh, thank you so much to one of my subscribers. And you'll see the subscribers by their names. They'll have like a purple chemistry symbol. Okay. OMG Spesa, thank you. Thank you so much. Thank you. Now, I don't do organic though, Leah. I don't do organic. Organic and I have a love-hate relationship, if I'm honest. Okay. But I do know a couple of people that do organic. So if you want me to give you those names, I can give them to you. You just DM me and I'll send you their information. Yes. Okay. All right. So with 32, you've got dinitrogen trioxide. So di means 2, nitrogen is N. When we rewrite this, it's N2. Trioxide is O. Well, the 3 is for tri. Oxygen is O, so you get O3. And when you bring the 2 together, you get letter B for 32. N2O3. Good job, Beyonce, Ariel. Good job. Okay. Sulfur hexafluoride, number 33. Sulfur, which is S, okay, sulfur hexa. Now, in case you didn't know, I'm going to go back to my chart so you all can be familiar with these symbols. Okay, we know fluorine is F, okay, but here's hexa right here. Let me go back up here. Hexa is 6, okay? Hexa is 6. You guys got to remember these charts or these prefixes. It'll save you a lot of time. So you've got 6, but remember, you got to rewrite this as F6 and bring the S down, so you get SF6. So letter A is the answer for 33. Yes. 34. 34. Okay. Phosphorus is P. And then penta, like the pentagon, okay? So right here, phosphorus is P, penta is 5, fluoride is Cl, but we have to rewrite this as Cl5 in that order. Bring the P down and you get PCl5. So your answer is letter A. Thank you, Sean. Appreciate those prefixes in the chat box. I love number 35. I need to drink more of it. I love the fancy name for it. The next time you go to the restaurant, ask for some dihydrogen monoxide. Dihydrogen, di is 2, hydrogen is H, but you rewrite that as H2. Mono is 1. Oxygen is O. Bring that down, you get H2O. Dihydrogen monoxide. So letter A. Yes, ATE and IDE, that's when we get into the polyatomic ions. So, and I did not cover that yet, but we're going to do that tomorrow. So right here, let me just show you, okay? Since you had asked about it, the polyatomic ions tend to have those charges, like ITE and ATE, IDE, and so forth. Oh, wow. You have class tomorrow. We're going to finish, we're going to continue that on, yeah, and then Wednesday, I will not be here Wednesday. No, but usually if I'm not on during the morning time, I come on in the evening time. So I might, don't quote me on it. If I do go live in the evening times, guys, you all can check my profile and it'll tell you what my schedule is. It'll tell you when my lives are, okay? All right. Yeah, we'll get into that tomorrow, New Off. Yes. Yes, we will get into that part tomorrow. Okay. All right. Now, right here. Okay, yes. Yes. And then you can always go to my YouTube channel. Yes. And I'm going to be putting some shorter versions of these clips of these videos so that you guys can see them, okay? Yes. I know y'all want to see everything. So just make sure that you all have my notifications on, because a lot of times you don't know when I drop videos and then, you end up missing out on them. So yes, yes. Okay, so yes, guys, we're going to close out. Okay, we're going to close out on 36 and 37. 36 and 37. You've got nitrogen trifluoride. Okay, I want y'all to see if you all can tell me what the answer is for 36. And then carbon tetrafluoride. Carbon tetrafluoride. Here's how you do process of elimination. Remember, you're not swapping charges, so nitrogen should not have a number beside it. So we can get rid of letter D and letter B, because you should not have a number beside nitrogen. Tri means 3. So we know our answer is letter A for 36. Same thing for carbon. You should not have a number beside carbon, so we can get rid of letter C and letter D. Tetra means 4, so therefore letter A is the correct answer. Excuse me, guys. Excuse me. Okay. So thank you, She Means Business. You have a great day as well. Thank you so much for always showing up and showing out, knowing your stuff. Thank you, thank you, thank you. Appreciate you. Appreciate you. And all of you guys, I appreciate each and every one of you all. If you ever have questions and you